Okay. Okay, so we can start? Yeah. So I will present you some work that we do at our research center in Casa Paganini, but I arranged that like so something in between a lecture and a presentation of our research activities. So I will show you what we do, but I will also try to give you some concept about the technology which is behind all of that. This technology is called multimodal systems. So it is, let's say, a computer technology. So it is something inside the computer science, computer engineering, and so this could be something that can be useful for you to know at least the basics of this technology. Before starting, I will tell you a few words about our research center, which is Casa Paganini, that you see there, which is in Genova, in Italy, and this will be the place for the next pilot of transfer in April. And you see this is the lab, which is quite particular, because we have a big auditorium, let's say, a big room equipped with a motion capture system. You know what is a motion capture system? It is a system that is made by several video cameras that you put all around in a big room, let's say in a big space, and the system is able to track some little markers, which are small balls that you put on the body, and then the system can reconstruct the movement of the balls, so the trajectories, with a very fine grained resolution. So we talk about 1 millimeter of a resolution of tracking. And this is used, for example, in movie making, when they do the characters for movies. Then, of course, what they do is to record a real actor that does the movement of the animated character, and then on the top of this movement they build the character. So we have a system like that here, and we use it for experiments because we work on human full body movement, let's say. And then there is another lab on the top, and from this lab we can observe what's happening, what is happening here. So for example, if there are dancers or actors performing there, we can observe them from here and we can measure what we do. And this is a very ancient building. You see that this is the stage. There are frescoes, so it is quite a particular environment. What we do is, this is our research. We have two major areas. One is affective computing. So what means is, so you just an example, very trivial example. So the way in which you behave, the way in which you do an action, can have a kind of expressive content associated with it. For example, I can say very calmly, please sit down here, or I can say, please sit down. Okay? So you see, same action, please sit down, but performed in a very different way. So what we do is to analyze the way in which the action is performed. Not so much which is the action, but how it is performed. This is affective computing. Social signal processing is to analyze, by technology, how people interact together. So for example, yesterday, you were in a team, and so we could analyze, for example, how how much the team is well engaged, which is the cohesion of the group, who is the leader of the group, how the group is synchronized when they perform actions. Again, automatically. So this is another area of computer science, which is called social signal processing. And our research in these two areas can be applied to several application areas like performing arts, education, well-being, cultural heritage, rehabilitation, and so on. So this is more or less a big picture of what we do. And now I started with an example. Not much. Okay, this is Cronaca del Luogo. This is a music theater production, opera, by Luciano Berio, who was a very famous computer music composer of the last part of the last century, so second half of the 19th. So he worked, you see this one in 1999 at the Salzburg Festival. And this was one of the, for me, I was not directly involved, but because I was a master student at that time, I was doing my master thesis. And so it was the first opera that I could touch, let's say, with my hands. And you see that there is this actor here, and who is David Moss, and you see that he has this helmet on the head. What he does, I have to go back. What he does is this is the guy. He moves from one side to the other of the theater, of the stage. You see now he's there. And just to avoid to bore you with the sound. You see? He goes from one side to the other. And he wears, you see here the sensors, this small thing around here. These are sensors that he was wearing. You know, this is 1999, so the technology was very different from what we have today. And so the idea was that technology, so a camera at that time, could track this guy moving from one side to the other of the stage. And we could change his voice, so his voice was processed in real time, depending on the position of the stage. So he was acting a kind of twofold character. So on one side of the stage, he was a kind of a wise man. On the other side, he was kind of a madman. And the processing of the voice changed so that the voice moved from low frequencies, let's say, to high frequencies to change the expression of the character. And then he could trigger some events by clapping on the sensor. So this was very complicated at that time because there was no technology to do it. Just a normal video camera, old video camera. And so what they did, because as I was saying, I was not directly involved, it was to put a LED on the top of the helmet. And so the camera could track the light of the LED moving on one side or the other side. And this was quite complicated, of course, for that time. So this is the kind of technology that we develop. So it is systems that can observe what a user, in this case the actor, is doing, and can make a response, let's say, by extracting some qualities of a behavior of the user and make a response for the user. So these systems are what we do, and an important thing is that these kinds of experiences that we had could be let's say, a way to inform, to drive our technological development. So here you see some connections between an artistic project and scientific and technological research. And for example, Cronaca del Luogo, you see, was, let's say, the trigger in a sense that made us start the development of ISO, which is a software platform that we used for 20 years to make these kind of things. It is a platform like, it is similar to what you have seen, not you because you are not you, you have seen this morning, Max that was showed by Joao this morning. ISO has the same concept, and so you have blocks, modules that you can connect all together, like Touch Designer, for example, another platform which is similar to that. We had many of these experiences, and all of these experiences led to technological developments, because you learn from the artistic experience, so you work with the artist. The artist, of course, doesn't know too much about the technology, and so he needs so you need to discuss with them, but then also you learn from them. And so this is a way to, which is very central for this project, for example, to work together and try to make advances for new technologies and for new artistic experiences, of course. So what is this technology? This technology is what is called a multimodal interactive system. Multimodal interactive systems means that it is a system, so it is a computer system. It's interactive because it allows people to interact with technology. Multimodal because it uses several channels to get and to convey information. What I mean for several channels, I mean that I can use my movement. When I said, please sit down, you see, I made a gesture. Sit down. I can use my face. I can smile. I can be more aggressive, let's say. I can use my speech. Please sit down. Please sit down. Speech is different. So a multimodal system is multimodal because it's able to gather data, capture all this data from different channels, and put everything together. And it is also a multimedia system because the response uses several media: video, audio, pictures, movies, lights, and so on and so forth, whatever. So what is this system? Is a system that, as already said, it is able to observe performance users and analyze the behavior and use all of this to produce the output. And so this is a very simple schema of a multimodal system. So you have the users, you have an input side where you get the data acquisition, you analyze the data, and we tell you what analyze means. You fuse together, why choosing? Because you get data from several channels, speech, face, gesture, and so you have to put everything together to get an understanding of what is going on. And interpretation, so from everything that you collected, you try to understand what the user is doing, what he's asking. So how to respond to it, to him. And how to respond is this mapping from input to output. So you know what you know, hopefully you know what the user is doing, and then you try to find out which is the best response for the user, what the system should do. And here you have strategies, which are, let's say, high-level ways to rules, let's say, that you can design to respond to the users. Then you have decisions, so you have the rules, and then you have to find out which is the rules that apply at that time because of the input. So I'm asking to sit down, and so you sit down. Okay, so this is the rule, and you apply that rule. Metaphors are like in standard human-computer interaction. You know that a metaphor is a way in which you represent in the computer environment something which is familiar in the real world. Like the desktop metaphor, which is the most famous one. So you represent a desktop on the screen of a computer, because you know how a real desktop works, that you have tools on it, you have documents, you have folders, and so you replicate the same idea of a real world in the computer world. Why? Because people, users, who are not technologists, but they, of course, they live in the real world, they are familiar with that, and so it is easier for them to use the computer because it replicates something that exists in the real world. And so if you use a metaphor in the mapping, it will be easier for users to understand what is going on, because they find something which is already existing in their life. And finally, the output part, which is a synthesis, so you decide what to produce, and rendering, so you use the devices like projectors, loudspeakers, and so on to make the output. So this is more or less the general schema of a multimodal interactive system. And we developed this conceptual framework, let's say, to say what happens inside. So you don't need to see all of them. I will go through it, so we see it step by step. And the idea is that there is an input side, which is this one, and you go up from the physical signals, that is the microphone, which is here, up to concepts, and then on the other side, which is the output, from the concepts, you go back to the physical signal like the projector. So let's see what happens. If you want to know more, there are some papers that I can give you, or you can find them. So I will do an example focusing on movement, which is what we study, okay? But you can replicate that for the other channels, so for speech, for face, whatever. So let's start with the physical signals. And here we have the sensors. You see? Sensor for movement. So if you want to grab, I'm here in front of you. If you want to grab my movement, what you can do is to put a video camera. So the easiest way is to put a video camera like the one that is there, which is grabbing what I'm doing. And video camera, okay, that one is quite a professional one, but you can have from very low cost, like the webcam that you have on the computer, 10 euros maybe, up to several thousand euros. Okay? For example, in Genova, we have, now they are quite old, but when we bought them, we have two professional video cameras that cost like 80,000 euros each. Okay? The motion capture system that I was describing before, the 16 cameras that track movement with a very fine-grained resolution and precision, this costs like 150,000. And we needed 2 European projects to get it, okay? Because you can decide what should I do. I buy my home or I buy the motion capture system, more or less. Okay, so a very big range of different solutions. In the middle, you have something like this is Kinect, you know. Now it is not supported anymore. This is a camera that was produced for games. Then Microsoft was buying that, and this was used for the Xbox. And this is quite a particular camera because it is called a range imaging system. Because what it does is to give not just the image, but also some information like the position of, for example, the hands and the elbow and the shoulders and parts of the body in 3D. So you have the X, Y, Z coordinates of all these parts of the body. This is called range imaging because it also gives the distance from the camera. It is not just a 2D like the usual cameras. Okay, it is 3D. Then it was discontinued by Microsoft, so it is not produced anymore for several reasons, and I think, so they didn't say why, but what I think is that nowadays we are on the edge of, let's say, of a new paradigm for tracking movements. And so now, thanks to machine learning and deep learning in particular, we have algorithms that allows to do what Kinect did in the past, so the tracking of the points, by using just a normal camera. So you can take a normal camera, use a webcam, you use some models like, for example, Google MediaPipe, just to tell you one of them. The first one was OpenPose, 2016, 10 years ago. Then things improved, so OpenPose, for example, worked only in 2D, and so Kinect was still useful because Kinect is 3D. But then 10 years passed, and nowadays there are ways to do it in 3D, and MediaPipe is one of the possibilities. And more or less all the big companies have something like that. So Google has MediaPipe, and Meta has another one, and so on and so forth. And so now you can do the same things with a normal video camera. And so there is no way to use this anymore, because if you can do it with a 10 euros webcam, why should I buy a 500 euros Kinect? Okay? So this is the main reason why this was discontinued. So these are the sensors that are used for movement, say, mainly. Of course, these are, I think this is everything is video. Other possibilities are sensors that you put on the body, like accelerometers. And if you have a mobile phone, the mobile phone has an accelerometer installed. So if you just take the mobile phone in your pocket, you can measure the movement of the body by taking the acceleration of the mobile phone. So these are the sensors, physical signals. Then we go up and we have these low-level features. What are the low-level features? Low-level features are numbers, measures, that you take from the data coming from the sensors. Here I was putting some examples like energy. How much I'm moving in front of the camera. I can stay still like that, energy almost zero. I can move a lot of energy. There are algorithms, techniques, to measure the amount of movement, let's call it, because energy, in physics, energy is something very specific. It's kinetic energy, okay? Let's say the amount of movement that a camera can detect. Contraction is another one. I stay like that, I'm very contracted. I stay like the Leonardo man, like that. I'm very expanded. Contraction expansion is another measure that I can take. Symmetry. I can stay like this, which is symmetric. I can stay like that, which is not symmetric. This is a postural symmetry. My posture is symmetric or not. Movement symmetry, I move a lot here, I don't move there. So this is a dynamic symmetry, not a postural. The idea is that I can extract some numbers. So you see that we move from the physical world to the abstract world of mathematics, from images to numbers. Okay? And these numbers describe my movement, or aspects of my movement. So the idea is that I get some functions, okay, that describe what is going on. These functions, these numbers, can be already used to produce a response, because of course I don't have to go too much up to concepts. I can even use very basic features like that ones. Very trivial example, I want to control the intensity of sound, so instead of rotating this knob here, to control the intensity of the sound, I would like to do it with my movement like up, down. Or I move a lot, high intensity, I don't move, muted. What I can do, I can take, so if it is up, down, I take the coordinate, the y coordinate, if it is x, y, z, of my hand, and I connect this with the knob of the intensity. If it is, I don't move muted and move a lot high intensity, I take energy. And I do the same. You see that even with these very simple things, I can already do some response. And these are some examples of what I can measure. Of course, kinematics, speed, acceleration, and all the statistics of kinematics. Then global measurement, energy, contraction, expansion, direction, if I move that way, if I move this way, if I move downward, upward. Measure from psychological research, so some psychologists, they analyze the movement and what we communicate with our movement, like Boone and Cunningham, De Meyer, Albert, and others. Measure from artistic research, from choreography. So I don't go into Laban's theory of effort, but there is Laban was a choreographer, and he coded the movement, and not only dance, movement in general. And he developed a theory, which is a theory from choreography, not from engineering or science. Okay, but he defined some dimensions for what he calls effort. And the dimensions are time, weight, flow, and space. And so you can try to measure these 4 dimensions. And then analogies with what we do in audio, like intervals, frequency analysis, and things like that. But I don't go into much details, and I will show you instead an example, which is an invisible line. This was something that we did in a project which is quite old, Comedia. This was a kind of a EU culture project at that time. And what we did here was to have one person in Genova and another person in Paris, okay? Or in Hamburg, because the 3 partners, Genova, Paris, Hamburg, connected through the network. That was not the network that we have today, because it was not 20 years ago, but more or less, okay? So, slow network, let's say. And so what we did was to measure, so you have the person divided into halves, right and left. And so what you see is half of a person is me, the other half is a person in Paris. Okay? I move, I do something, and the system measures the qualities of my movement, energy, contraction, symmetry, and so on. The same happens in Paris. And we have to synchronize in some way. Okay? If we manage, if we can synchronize, then the award is that I can see the person in Paris, and the person in Paris can see me in Geneva. So this is the award that you get if you succeed. And there was also some sound to help people to do the job, let's say. So this is a very, very simple example, but maybe it's just, the movie is just 2-3 minutes, so we can go quickly through it. It's a very simple example of how you can take some features, some numbers that describe the movement in this case, and make an installation which is something in between a performance, let's say, and a museum installation, because the performer is the user, so it's not a professional performer, but in a sense it is artistic. Okay? So this is Casa Paganini, so this is the person. So you could see only the silhouette, black and white, so not the real person, of course. And this was done also for technical reasons, because the network at that time was not so fast to send color images. Black and white we could do. Okay, so you see half is you and half is the silhouette black and white of a person in Paris. Okay, here you see what we extract, like aggressive, calm, and so on, and then we compute the synchronization between the two others. So here we see the list. Fluidity, so whether the movement is like fluid or irritating. Contraction, asymmetry, quantity of motion, so the amount of movement, energy. This is a session, a real session, so this guy was in Paris, and then when they succeeded, you see that the picture of a person on the other side appears. So you can see who is the person on the other side. So this is something that then with COVID became usual to do a remote, what is called a distributed performance or a remote performance. But this was like 10 years before COVID, and this was not so common, let's say. Nowadays it is of course much easier to do this kind of things. Let's go up, mid-level features. So low-level features are just numbers, functions, time series are called. So a sequence of numbers that describe how much I'm moving, energy. Then when we go up, what we want to do is to identify single units. Like I do a circle, I stop, this is a unit. And during my movement of it, while I'm making the circle, so this takes some time, of course, and I can express something with, I can say something, I can use my face to express something, and so on. So this is called segmentation. So to find single units in a stream of gestures. So I do a circle, when I stop, when I do a triangle, when I stop, when I do a square, and I stop. I made 3 gestures, 3 units. But why it is important? Because the units, the single units, have some meaning. If I do a circle, this has a very specific meaning. It is not like only energy or only contraction expansion. It has a meaning. And so what we do with segmentation is to find units that have a meaning. And the units that have a meaning are called gestures. There are several definitions, so I don't go into the definitions of gestures, because otherwise it's too much, made by psychologists mainly. But I just say that gestures can be used, for example, to represent the real world. For example, if I say that this table is big like that, this is a gesture that I make to give an idea of the size of a table, or to communicate something. If I say, okay, this is a way to communicate that this is good, or a pointing gesture. So look at that door. This is another gesture that has a meaning, and so on. So the units can be analyzed further, and so you can start from the numbers that you collected, low-level features, to give one vector of numbers, one sequence of numbers, to a gesture. So you can characterize a gesture by a sequence of, I don't know, 10, 20, 30 numbers that describe what happened. Okay? So this is an example. So I don't have the movie of that, I only have the picture, but this was an installation that we did in a museum in Genova, Palazzo Ducari, almost a museum, let's say. It is a container, but of different exhibitions. And the idea was, you see that this guy is doing this gesture, was to recognize this gesture, to look inside a picture of an ancient building in Genova. So there is a street which is Via Garibaldi with a lot of monumental buildings. And so here in this installation, the visitors could go through the sequence of buildings, just like moving like that, so I can do like this, and the strip of buildings move. Then I can stop on one building, make this gesture, and go inside, and see what is inside the building. And what you see inside, for example, this is the ceiling. Okay, the ceiling, which is, in this case, it is quite far because the rooms are, so the height is quite like 5 meters and 6 meters high. So there is a fresco on the ceiling there, 6 meters high, and so it is quite difficult for people to stay and look at that. So if you go in the real place, you will have to stay like that to see what is there 6 meters far. But in this way, with this gesture, you can go inside and you can see the details of this fresco in a way that it is not possible to do in the real place. Okay? Because the real situation is very different. And so here we use gestures, and this is also, I will say, a way to use technology. That is, just as a take-home message, when you use technology, you should use it not for replicating something that you can do in the real world, because it is better to do it in the real world, up to now. So the idea is to use technology for doing something which is not possible in the real world. For example, to see the details of a fresco which is 6 meters high, it is something that you cannot do because you would need to go up close to the fresco to see it, but of course you cannot. Technology, on the other hand, can help you to have this experience, even if you cannot go there. Okay? So it is a way to do a technology which is not a surrogate of the real world, because if it is a surrogate of the real world, I prefer the real world, I would say. It is something that I cannot experience in the real world, so I use the technology as a means to get the experience. So this is about the usage of gestures. So let's move to the final step, which is the concept and structures. And so here, what we do, so we have a sequence of gestures, and we try to find out what the user wanted to communicate. For example, the emotions. If I say, please sit down, this is emotions. I am angry, or I am calm, relaxed. And so I can make a machine, a computer, that I can take all this data and give me a label, which is the emotion. Emotion, of course, is not, could be questionable because we don't have a fixed emotion every time. We have maybe some feeling, but not exactly an emotion. But you can have some less, let's say, less well defined concepts like if I am stressed, I am calm, I am relaxed. So it is not I am happy, which is complicated, but I'm relaxed, I'm not so much stressed, or things like that. So this step, this final step, I don't go into the details, usually this is done with machine learning. Machine learning, you know, it is there are techniques to learn from data, to give a label to some data. And the label could give emotion, happy, anger, sad, so on and so forth. So what we do once we have this, we try to use it. So this is an example. This is the GAMEP dataset that was recorded in Geneva by Prof. Scherer. So you see these are actors that were asked to act an emotion. And so this was data used to train the algorithm to learn which is the emotion which is expressed. So how to use it? So this is another opera theater performance, which is by Nicola Ferrari, who is a teacher of our master degree. And this was presented during the International Conference on New Interfaces for Musical Expression in Genova. And here the idea is that you see we have 4 dancers that dance in 4 different areas of the stage. This is the stage of Casa Paganini. And the idea is that the 4 areas of the stage are connected with the 4, let's say, usual voices of opera, which is contralto, tenore, soprano, and basso. Okay, so you have music chorale by Bach, that has the 4 voices. So contralto, which is female, let's say, mid-range, tenore, male, mid-range, soprano, which is female, high-range, and basso, which is male, low-range. So, if you move inside one of the 4 areas, you will listen that voice. So if I'm alone, I stay here, so I stay in this part, I will listen to the soprano. Then if I move, I go here, I will listen for the tenore, and then here the soprano, and here basso. Okay? But if I am alone, I can only listen to one of them. If we are 2, we can listen to 2 of them. If we are 3, 3 of them. If we are 4, we can listen to everything. But there is another complication. That is that the 4 voices have 4 different emotions. So the singers sung the chorale in 4 different ways. One is a calm way, a solemn way. Another one is a more aggressive way. And then there was a kind of sad, melancholic way, and a kind of happy, joyous way. Okay? And so, which of the 4 interpretation was reproduced? It depends on the movement that I do. So if I stay here and I move very slowly like that, I will get the soprano in the sad interpretation. If I stay here and I am very happy, I will get the contralto in the happy mode, let's say. And so to reconstruct the piece, we need to be 4 people, and all of us should perform the same emotion, let's say. Because otherwise, if we perform differently, we will get something chaotic. Because okay, it is the same song, but with different interpretation, we will get the chaos. So if we are synchronized, let's say, in the emotion that we express, not in the movement that we do. Now we do the movement. Then we reconstruct the music piece. Otherwise, we get something chaotic. Okay, so this was one part of this piece, which is quite long, it is an half an hour performance. One part of it here is kind of 3 minutes. is about this game. So you see that here we use the emotional expression, let's say, to control which audio is played back. I will just show you a short excerpt because we don't have time, but there are other voices because there are also singers on the other side, but you can see them, but so this is a quite chaotic part. If they stop, silence, the only sounds are the singers which are behind, but not the automatic system. The singers are here. This is the joyful one, correctly reconstructed, because they are all of them are doing the same. Okay, so the final one was, at the beginning it was the chaotic one, and now the final one was the joyful one, correctly reconstructed. Now we go to map and go down. So how to map what we understood, hopefully, about the user. Could be energy, could be gesture, could be emotions, and so on. How to map it into a response. You have two major ways to do it. One is the so-called direct mapping, which is, for example, I take the energy, I control the intensity of the sound. So there is a direct mapping between the measurement that I take and the variable that I control. Very simple, very understandable by people. The problem of direct mapping is that it should work strictly in real time, because if I move a lot and then the change of intensity arrives after 10 seconds, I lose the connection. Okay? So the technology that I use should be good enough and fast enough to make everything in a time which is short enough for people to keep the correspondence between what they do and what they get. So this is direct mapping. Simple, but very hard real-time constraints, let's say. The other way is a kind of dialogue. So I do something and then the system responds. So here, of course, what I can do is I have more time, because if it is a dialogue, the user can wait for a short time to get the response. Okay? And in this way, usually I need to go up in the layers, because it is not enough to take energy contraction, but I should get something more structured, let's say. So these are the two major ways to do it. Once we do it, we do the opposite. So we start from emotion activities, especially content, qualities, and so on. We go down and we select what is our interface to the user. Could be a robot, for example, could be a character in a virtual reality game or in augmented reality. Could be just the environment. I can change the lights, I can use the sounds, I can use the projections, and so on. Now I take the idea of a robot and or character. Then I go down, I select the gestures that the robot or the character should do. Then I go down, I create the trajectories that make the gesture. And then finally, I will give the trajectories to the actuators, which is the real robot or the character in the virtual reality environment. And the robot or the character will do my response. Okay? So this is the way in which I go down to create the response of the system. And so, one final example, which is this RTVisive 2. So this was again, which is again an old story. So now you can see it, but it is 1998. Okay? But it is just a way to show you, because there is a robot inside, so that's why I selected that. And so in this case, what we had, this was an exhibit, again in Palazzo Ducale. And there I was a master degree student, so I was doing my master thesis at that time. And so I programmed some part of the movement of a robot, because I'm a computer engineer, so this was my role. And so the idea is that there is this robot that goes around in the exhibition with people, and the robot tries to catch the attention of the visitors and to make to be kind of guide for the visitors to bring the visitors around. And the robot has a very, I will not say trivial, but very basic models of emotion, which is a competitive model using a SOM network at that time, a Conan network. And the idea was that the robot could have 4 different emotions. Again, the 4 basic emotions, happiness, sad, grief, sad, anger, or fear. And the emotions depended on what people was doing around the robot. So if people follow the robot is happy because he's doing well in the role of being the guide of the exhibition. If instead the people are all around the robot, so that the robot cannot move, he becomes angry because he cannot move around. Okay? So this was the idea, and this idea was communicated to people in 3 ways. One is the movement of the robot itself, that could be calm or more jerky, let's say. One is the sound, because the robot has some loudspeakers inside to replicate some sounds. And the third one was a deformation of an image. So the robot had the camera here, and the camera was taking the pictures around, and the pictures were deformed according to the emotional state. So for example, if the robot is angry, you get a kind of spiral that deformates the whole picture. So this image is projected onto screens around the exhibition. So I will show you that, and then I finish with a last movie. The camera was here, in the eye of the robot. This is the model of emotion. It is calm, angry, or melancholic. And this is the formed image depending on the emotion. The sound, so before that you were listening to ta 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 ta. The percussions are the expression of anger. You see here people could see these images. And now I finish. So of course the same approach can be used for the other modalities such as expression, speech, touch, whatever. And I conclude with the tools that we use. So we used ISEB, which is this platform that I said at the beginning, we developed after the experience with Luciano Berio, and nowadays it is quite obsolete, but what we are doing is to move to Python, so from ISEB to PyISEB, so we are bringing what was inside ISEB in a Python library, so that you can take this and use it for analysis of movement. And we are also using Touch Designer, because PyISEB can be imported inside Touch Designer and then used for analysis. And I finish with the last movie that our students gave me just half an hour ago, which is, so you will recognize Greta doing it. So this is an installation that they did just in the past semester, so the first semester of this academic year, because they attended a lab which is inside the master curriculum in digital humanities, which is made of 3 modules. And at the end of this lab, I just stop to explain. At the end of this lab, we organize usually every year, let's say, a final event in which the students present what they did during the lab. And so this is one of the installations that were presented this year. And we organized this event in Palazzo Reale, which is an important museum in Genova, which is a public event. So they do in 3 months some job like that. And then at the end of the course, this is presented to a real audience. So this is called Respirarte, and so this is an installation where you do some movement of opening, let's say, and what you get is a kind of landscape which is a calm, relaxing one. So the idea is that if you do relaxing movement, let's say, you get a relaxing view, which is taken from, let's say, artistic paintings, ancient paintings. And this is used also in the context of rehabilitation, because this is a way to stimulate people to make rehabilitation exercises. So you know that especially for old people, it is quite hard to repeat exercises if you don't have a good motivation. So this is a way to motivate them to do some movements that help them to let's say, rehabilitate some some motor capabilities that are not so good, let's say. So I will show you that, and then I finish. You see that the painting appears while she's doing currently the exercise. This is the painting that was selected I don't know what it is, but you know what it is. I don't know them. Huh? Okay. There's also the soundscape, which is the sound which is used, which is connected with the movement, of course. The rain. Of course, the rain is disturbing, and so you need to move to remove the rain. Okay? So you see that if you move, if you do the correct movement, the rain slowly disappears. The rain disappears and you see the painting appearing behind the rain. Okay? Okay. Thank you very much. If you have any question, of course, we are here.